right, ladies and gentlemen, so today we're going to start doing things with our polynomials. Multiplying, we did a little bit of adding them yesterday and subtracting them. We're going to do some multiplying today. So we're going to be multiplying a polynomial by a monomial. All right, we did monomials by monomials in the last chapter. You multiply the coefficients, you add the exponents of the same bases. So this is now just taking it, it's going to make it a little bit bigger. So what we're going to do then is we're going to combine and use our distributive property. All right, so we have to distribute first, which means, as a reminder, you're adding the exponents of the same bases. Then if there's any like terms to combine, you're going to do that, and then as always, it should be written in standard form. Okay, so it's putting together a bunch of different little pieces that we've worked on. So we're going to take this, so I have 5a squared on the outside, and I have this big thing on the inside. So I'm going to take, and I have to multiply 5a squared by each piece on the inside. All right, so ignore this for right now. Let's just worry about these. So I have 5 times negative 4 is negative 20. And then a squared times a squared, same base, I add the exponents, a to the 4th. Okay, so that's what we did. We did that last chapter. Well, now I'm just saying, okay, now I have to do it again. So I have 5a squared times 2a. So 5 times 2 is 10. It's a positive, so I write it as a plus. A squared times a would be a to the 3rd. Because remember, there's a little 1. 2 plus 1 is 3. Okay, now I have to do it one more time. 5 times negative 7 is negative 35. I don't have any a's over here, so I just keep the a squared. I look to see are there any like terms. There's not, because I have a 4, a 3, a 2, and it's already written in standard form. Okay, let's try the next one. So now I'm going to take and I have to multiply by a negative 6d to the 3rd. And I have to multiply it by every single piece. But I can do this. Take them one at a time. So negative 6 times 3 is negative 18. D to the 3rd times d to the 4th, d to the, that's supposed to be d to the 7th, even though it doesn't look like it. There we go, a little better. Now, negative 6 times negative 2, always taking the sign of what's in front. It's going to give me positive 12. D to the 3rd, d to the 3rd, add those exponents, and you're going to get d to the 6th. Negative 6 times negative 1 is going to give me positive 6. D to the 3rd times d to the 1st, d to the 4th. Negative 6 times 9 is negative 54. I don't have any other d's to worry about, so we just write down d to the 3rd. No like terms in this case, and it's in standard form because we're going 7, 6, 4, 3. We didn't have a 5, that's okay. You're not going to always have every single exponent represented. Okay, now this one, now we're getting a little bit more complicated. I just have the 2 sets that I have to do. Well, I can do that. So I'm going to start, this one's going back to 7th grade. Just multiplying by my 3 out front. So 3 times 2 is 6t squared. 3 times negative 4 is negative 12t. 3 times negative 15 is negative 45. All right, I'm going to do the next one in a different color. So now I'm multiplying by 6t. So now I have to remember those rules from last chapter. So 6 times 5 is 30. T times t is t squared. And then 6 times 2 is 12t. Now I have to look to see, do I have any like terms that I can put together? So I have 6t squared, and I have a 30t squared. This is what we practiced yesterday. So, excuse me, 6 and 30 is going to give me 36t squared. I have a negative 12t and a positive 12t. Well, those are going to cancel each other out. Negative 12 and 12 is 0. And then I just have my constant term left, nothing to put with it, so I just write it down as negative 45. So in this case, we had some things that canceled out. I'm still in standard form because I go 2 and then no exponent. So this would be a binomial, degree 2, leading coefficient of 36. You have to know those words. Okay, let's try the next one. This time I'm going to multiply by a 2p. So 2 times negative 4 is negative 8. P times p squared is p to the 3rd. If you're not sure how I'm getting that, you better come and get some help. So 2 times 5 is 10. P times P is P squared. Okay. Now I have to multiply by a negative 5. So negative 5 times 2 is negative 10. Keep the P squared, because this one doesn't have a P. Negative 5 times 20 is negative 100. Now I'm going to look for my like terms. I have a P to the third. I don't have any others, so I'm just going to write it down. 8P to the third. 10P squared minus 10P squared. These, just like in the other example, are going to cancel each other out, and we're going to keep the negative 100. Please don't think that you're always going to have terms that cancel each other out. That's not going to happen. Okay, it's not going to happen every time. We're going to skip number 2. We'll do that one together in class, the one that's at the, or letter E, sorry, that's at the bottom of the page. We'll come back to that one. I want to get over to these. So solve each equation. So we did these. 7th grade, this year, we've done these. It's just now going to be a little bit more putting things together, and we're actually not going to really be able to even, well, I should say that. I'm going to shut up. Okay, let's just do the work. So I have to multiply through by my D, right? I have to always get rid of the parentheses first. So D times D is D squared. D times 3 is 3D. Over here, this time I'm multiplying by a negative D. So negative D times D is negative D squared. Negative times a negative is going to be positive 4D. And then I just copy the rest down. 9D minus 16. Combine my like terms. So my D squared minus D squared, those are going to cancel out. I have 3D and 4D, which is 7D, equals 9D minus 16. I have variables on both sides, so I have to get them on one side. So I'm going to subtract 9D. That was a pretty bad one. But 7 and negative 9 is negative 2D equals negative 16. Multiply by negative 1/2, because we really do need to do that, which gives me, I forgot the negative sign, gives me a positive 8. Okay, so a lot like what we did before, it's just we had these D squareds, but they ended up canceling each other out. Eventually, they're not going to cancel out, but we'll get there. Oh my gosh, this looks so complicated, but we can do it because we're going to take little piece by little piece. So first, I'm going to go through and distribute 2A. So 2 times 5 is 10. A times A is A squared. 2 times negative 2 is negative 4. Keep the A. There's that piece. Let me do the next piece. So 3 times 2 is 6. A times A is A squared. 3 times 6 is 18. Keep the A. Plus 8, because that's from over here. That's a bad 8. Okay, now I'm going to do the other side. Same thing, right? Doesn't matter how many sets of parentheses I have, I just keep doing the same thing. So A times 4A is 4A squared, because A times A is A squared. A times 1 is A. Okay, now I have to do this next one. So 2 times 6 is 12. A times A is A squared. 2 times negative 4 is negative 8. Keep the A. And then just plus 50, because there isn't anything over there. Now I'm going to combine my like terms. So I have 10A squared and 6A squared, which should give me 16A squared. I have negative 4A and 18A, which is going to give me 14A. Keep the plus 8. Over here, I have 4A squared, 12A squared, 16A squared. I have A and negative 8A, which is minus 7A, and I keep the 50. I have variables on both sides. They have to be on one side. So I'm going to subtract 16A squared first. So those are going to cancel out. Right? They completely canceled out. We've had that happen before. That's okay. So I'm left with 14A plus 8 equals negative 7A plus 50. Now I have to get the regular A's on one side. So I'm going to add 7A. So 21A plus 8 equals 50. Subtract 8 from both sides. 21A equals hope I did that right, is 42. Multiply by 1/21. So A is 2. So that huge long equation up there really is saying, guess what? A is only 2. All right, questions? Bring them to class. You might need to watch this more than once, but we're really going to have to work hard during class to make sure that we're getting the practice, because this is the basis for stuff you're going to use next year in geometry, the year after that in algebra 2, pre-calculus, all that stuff. So we really have to make sure that we're focusing on this and understanding what we're doing. As always, any questions, bring them to class, and have a good night.